Micro tugs. I remember when cameras were the size of bricks, and our parents packed them like luggage. Oh, wait, I am the parents. I packed them like that, too. Moving further backwards, their first computer filled a room. How crazy is that? In this video, we'll analyze how far tech has come. Because now we got salt-sized sensors, fingertip robots, and teensy-weensy systems that make us want to say, I'm going to squish you. Who's a little pokey genius? Smushy, smushy, squishy tech here. Come after us. Music. These micro tugs are small, ultra-lightweight climbing and pulling robots designed to move loads many times their own weight. Each unit measures about 1 in x1 in and weighs between 0.4 and 0.4 ounces. They operate using one of three mechanical systems. The first design uses piezoelectric biomorph actuators which flex. When powered, this version moves in fast, short steps up to 10 steps per second under load and can pull objects weighing about 10 times its own body weight. The second design uses shape memory alloy wires that contract. The Arma scooter, created by Japanese company Shimizu, is a lightweight electric scooter designed for ultimate portability. Weighing only 10 pounds, it folds down the size of a book in less than 30 seconds, making it easy to carry in a backpack or by its built-in handle. Ideal for short city trips, it supports riders up to 220 pounds and reaches speeds of 15 miles per hour. A full charge via USB-C takes about 2 hours, providing a 7 to 10 mile range. Solid rubber wheels, thumb button controls, and a digital display for speed and battery ensure smooth, practical, everyday commuting. This camera is no bigger than a grain of salt, about 0.02 inches wide, 0.5 millimeters. It's designed for fields like medical imaging, robotics, and compact sensors where size, speed, and energy efficiency matter. Instead of traditional lens, it uses a flat optical surface with 1.6 million nanoscale posts that bend light to capture wide-angle, full-color images. Software and machine learning reconstruct the raw optical data, delivering clarity close to larger cameras. A new version with stacked metasurfaces processes visual data optically, recognizing objects up to 200 times faster while using far less power. Shine 2.0. This other pokey-eye product is a compact portable wind turbine designed for off-grid power generation. It weighs about 3 pounds and folds down to a size of approximately 13.8 in x4 inches. When deployed, the blades span 23.6 in, and the full assembly stands just over 3 feet tall. The turbine begins producing electricity at wind speeds around 8 miles per hour, but maximum output up to 50 watts is achieved in winds near 28 miles per hour. At peak performance, it can charge a laptop in under 2 hours or 3 smartphones in 1 hour. It also contains a built-in 12,000 milliampere lithium-ion battery. Flyability Ilias. Further, a rugged inspection drone built for tight industrial spaces, such as mines, tunnels, power plants, tanks, and other confined or hazardous areas where human access is either limited or dangerous or both. It uses a duct fan, quadcopter design with 4 brushless motors and 5 inches propellers. Fully loaded, it measures roughly 19 in wide by 15 in high and weighs just under 4.4 pounds. With its standard battery, it can hover for around 12.5 minutes or about 9 minutes when the LiDAR is active. It is controlled by a 2.44 GHz RC link with 128-bit AES encryption with control range of up to 1,640. Foot sensors include an inertial measurement unit, magnetometer, barometric altimeter, stereo vision, cameras, time-of-flight rangefinders, and on-board LiDAR. The inspection camera records in 4K resolution and can detect features as small as 7,000 of an inch. From a distance of 1 foot, it uses angled LED lighting to highlight surface flaws, and a distance lock to maintain consistent framing. The onboard SLAM system builds live. Three-dimensional C-Star S30. Up until now, saying we have a telescope usually meant a big long device and even one of those cool setups like a tower room or a balcony. But here's how things stand today. Looking at a small digital telescope made for taking photos of the night sky, weighing only 3.6 pounds about. The size of a book around 8.3 x 5.5 by 3.1, and it fits on a regular tripod and can be used in hot or cold weather. The telescope has 2 built-in cameras. One gives you a zoomed-in view of planets or stars using a Sony sensor with a narrow field of view 2.46 degrees. The other gives you a wide view of the sky, 23.2 degrees, good for things like landscapes or the Milky Way. You can switch between the 2 views very quickly. It uses a 30 millimeters lens with special ED glass that keeps colors sharp and accurate. The lens has a 150 millimeters focal length and an f/5 ratio, which means it can capture a lot of light useful for dim stars or galaxies. There are built-in filters for different situations, like filters that block UV and IR light, filters for shooting nebulae 0, 3, and Computer 1. Computer that fits a full hardware platform into a unit measuring about 1 in x 0.9 in and 0.43 in thick. It runs on a 32-bit ARM Cortex microcontroller clocked at 48 MHz with 256 kilobov flash memory and 32 kilobov of RAM. It includes 400 MGB of flash and 400 kilobov of RAM. The front features a 0.95 in OLED display with a 96x64 pixel resolution and 16-bit color. Input is handled by 3 programmable buttons. A microphone, a 3-axis accelerometer with temperature sensing and an ambient light sensor. Combined with the onboard RGB LED, the light sensor can assist in basic heart rate detection under proper conditions. For storage, there's a micro SD card slot supporting up to 512 GB using a push-push eject system. A GPIO header provides access to hardware interfaces. A micro USB port connects directly to the onboard microcontroller for power and software updates. The board includes USB charging delivering up to 600 milliamps and features Razer DXD drift trike. Further, a 3-wheel vehicle designed for controlled downhill drifting on smooth pavement. It uses a welded steel frame combined with a wide rear axle measuring approximately 31.2 in, which provides a stable base during turns and slides. The front of the trike includes a motorcycle-style triple crown fork with seal bearings and a double clamp for added rigidity. A 20 inches pneumatic front tire on an aluminum rim allows the rider to start with BMX style, pedaling before gravity takes over. The rear wheels are 10 in wide and made from high-density polyethylene. They are mounted on high-speed bearings and include chrome hubcaps. The trike features flat handlebar, Sony AS-DT1, and smaller. We moved to this tiny 3D sensor that's smaller than a golf ball and weighs just under 2 ounces. It's made for machines that need to sense depth clearly, but don't have much room or power to spare. It works using a method called direct time of flight with a special SPAD sensor, short for single photon. Avalanche diode. This setup measures distance with an accuracy of about 2 in from up to 33 feet away, and its resolution can go as fine as 1/100th of an inch. Each frame gives a 576-point depth map, covering a 30 degrees field of view, and runs at up to 30 frames per second in normal. Foam. Sticking with robots, here's a soft robotic system that moves like a muscle. It's called foams, short for fluidic origami-inspired artificial muscles. It can shrink to less than 10% of its original length, bend, twist, or stretch in many directions, all powered by vacuum pressure. Each unit has 3 parts. A. Foldable frame like origami, a soft outer skin and a fluid inside. When vacuum pulls the fluid out, the structure collapses and moves. When the fluid is let back in, it goes back to its original shape. The way it moves depends on how stiff the skeleton is, how the folds are arranged, and whether it uses air or liquid. Air makes it move faster, while liquid gives it more strength. Jet-powered scooter. A modified electric scooter fitted with a working jet turbine. The base vehicle is an all-wheel drive off-road scooter, most likely the Fto Beast with fat tires, front and rear suspension, and hydraulic disc brakes. It was built to handle rough terrain, but here it's been upgraded to handle speed. The major change is the addition of a jet engine mounted at the rear. Originally designed for high-end remote-controlled aircraft, this compact turbine has been modified to deliver about 100 pounds of thrust, enough to push a full-size adult. It's part of a bold combination. Jet propulsion added to an electric scooter frame. The turbine is attached using custom-made steel brackets that are shaped, welded, and bolted into place. Fuel is stored in 2 thick aluminum tanks mounted near the rear seat.